You could be faced with a situation where you can use either difference of squares or difference of cubes factoring. The idea behind this video is to show you that it's probably best for most people to use difference of squares factoring first, then use difference of cubes factoring. And this video is going to show you why that is. But of course, both methods ultimately work. It's just one's a little easier than the other. So let's show you why. If we were given the expression x to the 8 minus x squared, the first thing we could do is common factor. Common factor out x squared, and our second factor would be x to the 6 minus 1. Now at this point, we recognize that's both a difference of cubes and a difference of squares. Now, why is it a difference of cubes? Because x to the 6 is x squared quantity cubed, and 1 is 1 quantity cubed. It's a difference of cubes. It's also a difference of squares, because x to the 6 is x cubed quantity squared, and 1 is 1 quantity squared. Now again, the idea behind this is that we're saying it's probably best to think of it as a difference of squares first. So let's call that method a 1. Let's use difference of squares factoring first. We've factored out the x squared, of course. Now, I'm going to view x to the 6 as x cubed quantity squared and 1 as 1 quantity squared. That allows me to call x to the 6 minus 1 x cubed minus 1 and x cubed plus 1. You can see where my cursor is. We've taken x to the 6 minus 1, used the philosophy of difference of squares, and it's now x cubed minus 1, x cubed plus 1. Now we recognize that in the first factor, we actually have a difference of cubes. So we can call it x minus 1 times x squared plus x times 1 plus 1 squared. And in the second bracket, we have a sum of cubes. It's x cubed plus 1. So we can call that x plus 1 times x squared minus x times 1 plus 1 squared. Now we have a trinomial and another trinomial in this other bracket. We're going to simplify those trinomials, reorder our factors a bit, and we have a nice final statement of what our factors are. It's x squared times x minus 1 times x plus 1 times x squared minus x plus 1 times x squared plus x plus 1. Relatively straightforward, and we got there by using a difference of squares factoring first and then creating a difference of cubes factoring. Now, what if we'd have gone the other way? Suppose we think of it as a difference of cubes first. Again, to show you what we mean, this second factor, x to the 6 minus 1, we can think of that as x squared quantity cubed minus 1 quantity cubed, therefore making it a difference of cubes. Well, if we do that, if we let a be x squared and b be 1, then we've got a cubed minus b cubed, which is a minus b times a squared plus ab plus b squared. We ultimately get x squared minus 1 times x squared quantity squared plus x squared times 1 plus 1 squared. And ultimately we get x squared minus 1 times x to the 4 plus x squared plus 1. Now we recognize an opportunity where my cursor is now to say that x squared minus 1 is x minus 1 times x plus 1. So what we've done by using difference of cubes factoring first is we have factored x to the 6 minus 1 into x minus 1 times x plus 1 times x to the 4 plus x squared plus 1. And so putting it all together, we see x to the 8 minus x squared is x squared times x minus 1 times x plus 1 times x to the 4 plus x squared plus 1. But if you look at what we got when we used method 1, where my cursor is now, we were able to somehow break this x to the 4 plus x squared plus 1 factor into x squared minus x plus 1 times x squared plus x plus 1. Well, we can somehow perhaps factor the expression x to the 4 plus x squared plus 1 directly to x squared minus x plus 1 times x squared plus x plus 1. How do we do it? Well, often, when we have a trinomial with exponents on x of 4 and 2 and 0, which we do here, x to the 4 plus x squared plus 1, which is the same as 1x to the 0, we can create a difference of squares by using grouping. What we can do is say, okay, we've got this x to the 4. I know that x to the 4 is x squared quantity squared. And I've got this 1, and I know that that's 1 quantity squared. So what we can do is say to ourselves, what is x squared plus 1 quantity squared? Well, x squared plus 1 quantity squared is x to the 4 plus 2x squared plus 1. So what we're going to do is we're going to, instead of saying we have x to the 4 plus x squared plus 1, we're going to say we have x to the 4 plus 2x squared plus 1. Well, how are we allowed to do that? We're allowed to do that if we're then honest about it and subtract that x squared off of the end. Now, what was the point of that? Well, what we've just done is we've created x to the 4 plus 2x squared plus 1, which is in fact x squared plus 1 quantity squared. And we're subtracting x squared. We have a difference of squares, believe it or not. If we let a be x squared plus 1, and we would then be able to say we have a squared minus x squared, which would of course be a minus x times a plus x. So that would mean x squared plus 1 quantity squared minus x squared is the same as x squared plus 1 minus x squared plus 1 plus x. We would then reorder the terms because generally speaking, like we see at the bottom, we don't order trinomials with the squared term, then the constant term, then the linear term. So what we do, we reorder them, and we are able to say that x to the 4 plus x squared plus 1 is actually x squared minus x plus 1, x squared plus x plus 1. So then going back to what we had in the second last line on this slide using method 2, we had x squared times x minus 1 times x plus 1 times x to the 4 plus x squared plus 1 is really x squared times x minus 1 times x plus 1 times x squared minus x plus 1 times x squared plus x plus 1. Now, most people find method 1 easier. I sure do. So as a general rule of thumb, you might remember that if you're given a polynomial to factor and you have a choice between using difference of squares factoring or difference of cubes factoring first, use difference of squares factoring first. You can still do it the other way, but it's just a little bit easier.